Okay, so question 8. What is the Kb value of C2H3O2 minus? The Ka value is 1.8 times 10 to the negative 5. Okay, so Kb is the base dissociation constant. And this pretty much tells us the strength of the base. So if you have a greater Kb value, then you have a stronger base. Similarly, we can have the Ka value, which is the acid dissociation constant. So when we have a larger Ka value, this tells us that we have a stronger acid. And then let's also recall what Kw is, which is the ionization constant of water, and its value is known. Kw is equal to 1.0 times 10 to the negative 14. And there is also a helpful formula that Kw is equal to the base dissociation constant times the acid dissociation constant. So if we wanted to solve for the Kb value, it will just be Kb is equal to Kw divided by Ka. So the Kw value we know is 1.0 times 10 to the negative 14. And our Ka value is given. It is 1.8 times 10 to the negative 5. Okay, so if we divide the two, we get a Kb value of 5.56 times 10 to the negative 10. So let's see what the junior tutor said. The base dissociation constant Kb is the measure of the likelihood of the base to dissociation. In general, strong bases completely dissociate, whereas weak bases only partially dissociate. The higher the Kb value of the base, the stronger it is, and the higher the tendency for it to dissociate completely. The equilibrium constant Kw is called the dissociation constant or the ionization constant of water. Kw value of water at 25 degrees is 1.4 times 10 to the negative 4, wherein the concentration of hydronium ions and hydroxide ions are equal at 1 times 10 to the negative 7. The Kb value can also be computed using the Ka and Kw value. Okay, so they showed the relationship between all of the different variables. Solving for the Kb value given above, 1.0 times 10, I think they mean to the negative 14, divided by 1.8 times 10 to the negative 5, gives 5.56 times 10 to the negative 10. Okay, so let me just fix this typo. Yeah, so it should be 1.0 times 10 to the negative 10. Or negative 14, sorry. Yep, so this solution is correct. I'll just fix typos that are shown here. And for the Kb expression,